Good morning. I'm Windsor Hsu. I'm on the engineering team at Datrium, and I'm really delighted to be here to talk about our Datrium blanket encryption. I've been working in the storage system, storage management, data management kind of technologies for quite a while, close to 20 years the last time I looked, and it's beginning to show. Before I joined Datrium, I was with Data Domain. I was a CTO and also an EMC distinguished engineer there. So again, very glad to be here, and let's dig in. Okay, so the need to encrypt data has never been stronger. Just open the papers and you see a lot of reasons why. Right? And a lot of the system vendors, storage vendors, they have responded by adding encryption capability to all the various products, but they all have issues. And I'll briefly talk through them in this slide. If you look at all these encryption features, they essentially can be classified into three broad categories. The first category, or the first approach, is use self-encrypting drives, or SEDs, SEDs. Right? And in this approach, the data is encrypted by the storage device itself. Sounds good, but what that means is the data is not encrypted until it gets to the storage device. And if you have a customer with existing storage devices that are not SEDs, if they need to deploy encryption, what that means is they have to go out and acquire new devices, provision new devices, and essentially manage a new pool of storage of SEDs, right? Self-encrypting devices. Okay? So most of the vendors choose this method because it's really convenient. There's not a lot of software development effort needed. You just go out and buy storage devices that are SEDs. Right? The second approach is to use the array controller. Essentially, there are CPUs in the storage array controller, so why not use it to perform data encryption? Now, the storage array controller is typically already the performance bottleneck, having to handle I/O processing for many hosts. And adding encryption to it just doesn't make it any better. Right? It just becomes an even bigger performance choke point. And this second approach also suffers from the problem that the data is not encrypted until it gets to the storage controller. Well, the third approach is to encrypt the data at the application level or the hypervisor level. So this approach makes sure that data is encrypted on the servers that are actually running the workload, so running the VM. Unfortunately, it has a very bad consequence. The consequence is, as a result of encrypting data that high in the stack, all of the subsequent data reduction techniques, the deduplication, the compression, they no longer work. Right? And these techniques, which we've seen, it actually reduces the amount of data by several factors. And it's not just the amount of storage you need, it's also the amount of replication bandwidth you need for replication. Right? All of that goes up by many times. So, and that's why we came up with the Datrium blanket encryption. It's kind of the new approach. It's the fourth approach to encrypting data that is designed to overcome all the issues I just discussed. With Datrium blanket encryption, you get end-to-end encryption with data reduction. End-to-end in the sense that once data enters the Datrium software, it is encrypted, and from then on, it stays encrypted within the DVX. And you still get data reduction with it. And we've made it really fast, and so fast, I think we talked about insane performance. This actually has no impact on that insane performance. Right? And the performance scales as you add workloads, as you add hosts to support the workloads. There's no hardware dependency. It's software driven. It offers you all the flexible advantages of that. Right? So this Datrium blanket encryption is enabled by the Datrium architecture, and Hugo went over it this morning. So in the Datrium blanket, in the Datrium architecture, we have DVX software running on each of the hosts. They can be a Datrium compute node or any other host. So there are any other hosts, any other servers that you attach to your environment. So this software is what we use to perform the Datrium blanket encryption. And what that means is the moment data is received by the DVX software, we encrypt it. And from then on, it doesn't matter where it goes within the DVX system. It can go to the local SSD drive or the NVMe drive. It can also go across the network to the disk drives on the data node. Doesn't matter, all the data transfer is from then on encrypted. So we call this end-to-end encryption or encryption, a life cycle encryption. The data is encrypted within, throughout this life cycle within the Datrium system. And we do all the compression and the deduplication processing before we do the encryption. So it's all happening in the DVX software. It's all using host I/O processing power, CPU power, and it's done in such a way that we actually compress the data, perform the deduplication processing before we encrypt the data. And what that means is you get all the benefits of deduplication. You can turn on encryption, and you still get the data reduction.
By the time I turn all this on and then turn insane mode on, what's left to run VMs with?
Exactly.
The other 4 sockets in that 8U server Langer's going to sell you?
Yeah. Actually, it's a wonderful question. Wonderful question. A great segue. I hope, I'm pretty sure I didn't pay you for it, but I was very well punted. Okay?
You're welcome.
Hey, Windsor. So, bunch of questions, mostly based on like hypothetical scenarios around the end-to-end encryption thing.
Yes, but I'd like to get to that point, since that point was just raised, right, about performance.
Okay.
Well, we actually make it go really fast. And there are 3 reasons, 3 key reasons why we can go really fast. The first one is we actually use the AES-NI engine that Intel and AMD has built into all the processors for many years. It's already sitting there on all the processors. It's used quite heavily in the Apple laptops. But on the servers, they're mostly idle. Right? That engine is just sitting around with not much to do. And we leverage it to perform our encryption. So it is otherwise idle on those servers. And we leverage it to perform encryption. That's one part of it, the AES-NI hardware assist. It's hardware assisted, it's already there. You don't need to do anything to procure it, to buy it, to set it up. The second point is we use the FIPS approved algorithm, AES XTS 256 with 512-bit keys. It's as strong as you can get. And that algorithm is specially optimized to run on the AES-NI engine. So you get really good performance. The third point is the architecture. The architecture is such that, the Datrium architecture is such that we use all of the compute resources on all the hosts. So as you add more hosts, you get more of the AES-NI engine, and you just scale beautifully. So virtually no performance impact when you turn on encryption.
So if I have to paraphrase before you move on to Nick, the overhead of what you're doing there is low, which is why you can afford to do it.
Exactly.
At least in terms of which resources the VMs would need. They're not going to be using that anyway.
Correct.
In most cases, so
yes.
The impact to them is low.
Exactly.
Okay.
Yeah, it's a great point. The NI engine is mostly unused in 95% of servers, and people don't turn them on. Where are the constraints of where are your kind of invisible walls of encryption? Like what happens when you go to another, you mount the same volume to a different host cluster, or you want to move data? What's data mobility, I guess, is where I'm going. You see it's end to end, but I mean, when you're moving between DVXs, when you're moving between host clusters, moving between vCenters, where's that line stop where you're going to have to decrypt the data to be able to move it?
Okay, that's also an excellent question. Right, the Datrium encryption works currently at the Datrium data store level.
Okay.
So as long as you're within the Datrium data store, it continues to be protected.
Okay.
Once you move out of the Datrium data store, then yes, you're right.
For remote sites, you have to use SAN-to-SAN replication here.
What was that?
For remote sites, you have to use SAN-to-SAN replication here then.
So actually, Zala and Boris is going to talk about our Datrium replication.
Yeah, but it's still SAN-based replication.
It is Datrium-driven replication.
But it's server-powered like everything else.
So it probably happens with the hypervisor.
Just to be clear, it is encrypted when it's transferred from one DVX to another and encrypted in that second DVX. So the data is always encrypted.
Yeah, what KMSs do you support?
Today, we support our built-in key manager, and we can support more key managers in the future. Currently, it is a built-in key manager.
I don't think that's bad. I mean, I think a lot of times this is the entry point for a lot of organizations to do a KMS, and they don't want to deal with a KMS.
Yes.
So I don't think that's a bad idea.
I think it's a bad idea personally.
Yeah.
We have a lot of companies that already have, a Gemalto or a Vormetrics
Yeah.
KMS that they don't want to deal with another
Yeah.
KMS that they have to then keep master keys for.
Yeah.
So, yeah.
Yeah, we hear both sides. This is our first step. It comes with everything you need to start encrypting data. And based on what we see, we can easily support additional key managers.
It only gets into a real big problem when you get into places that have multiple storage arrays, multiple encryption targets, and all of that stuff where you want to standardize your keys.
Or if you have to have FIPS2 and you have to have hardware KMSs and stuff
That's
like
fair.
that, that's when
true.
it starts to get really
That's true.
tricky fast.
Very niche customers, though, that are doing that kind of stuff. Right?
It's growing in popularity because the hardware's cheap now.
Yeah, we're not saying at all that we don't want to support external, third-party KMSs. We will. But it's, this is 1.0 for the encryption feature, and we wanted to make it simple. And so it's simple and easy to turn on, and it'll become more featureful over time.
So let me ask real quick, I'll just throw it out there. This is only VMware tailored right now, right?
It is
DVX,
VMware tailored.
DVX only supports VMware environments today.
So is
That's
there
correct.
any intention of expanding outside of that? Because I can see this very compelling in, let's just say it, container world, right?
Yes. I think we may talk about it.
Yeah, so certainly over time, it is our plan to support other environments. Again, we got to get started with the market behemoth. So
Exactly. I just was trying to get a sense of what that looked like going down the
yeah, because
path.
it's software and it's just our software, it's
Exactly.
easy to support in other environments.
Yeah.
There's not a it will carry forward.
Okay.
Yeah, so stay tuned.
Yeah.
There's more coming. And again, a great segue. We've got all of that, and we try to make it as simple as possible. And the Datrium blanket encryption, it is an integrated solution. Right? It comes with everything you need, a customer needs to start encrypting data, including a built-in key manager. Right? For most customers, they don't want to deal with the hassle of rolling in an additional key manager. It comes with everything you need. Also comes with features such as secure erase, where you can securely erase the data by forgetting the key. And we're talking about Datrium blanket encryption covers a lot of the devices on all the different hosts that you have, and also on the data node, right? But there is an encrypted agent that's running on each of the different hosts, and they're all working together with an encryption master on the Datrium data node, so that there is only a single point of management, right? There's only a single system that deals with all of these different NVMe devices, SSDs, HDDs spread throughout your cluster. Okay? And we've made it such that it's only one command to turn on. Right? If you think about it, there are no performance considerations. Turning on encryption is it actually makes for a very boring demo. I tried to figure out whether we should do a demo today, but you guys will be put to sleep, right? There's virtually no discernible performance drop. So,
Is it a checkbox attribute on the volume creation? Is that where you're doing it?
so the first version, actually, you need to do a CLI command.
Okay.
There's no checkbox yet in the GUI. You essentially just run the command.
Okay. And is that to enable the Intel NI stuff on the server host?
That actually is just to turn on the encryption. You have to provide a password, a passphrase,
Right.
and from then on, it's on.
Okay. So you're just creating your key. That's
Yes.
really okay. Got it.
So no performance considerations, and the best part is no storage budget considerations, right? There is no impact on deduplication or compression. There's no need to suddenly worry about, hey, you're going to run out of space, you're going to run out of replication bandwidth, because now there's no deduplication across the wire as well. And so all you have to do is turn it on with one command.
So do I need to turn that on before I throw any data on this array?
Yes, you do.
Okay, so you can't do it after the fact.
The first version, you do have to turn it on before you throw any data that you care about.
Yeah.
on. Yes.
Well put.
Well, yeah, well said.
And it is irreversible. I mean, if you want to switch it off, can you decrypt the data
Yes.
and use it?
If you want to switch it off, yeah, we will decrypt the data for you. In fact, we will always decrypt the data when you try to read it.